Spreadsheet to PLCIO utility. This exists as a utility when you want to create multiple PLC drawings at the same time. It's a powerful tool. It's a fantastic tool, but I will also caution it's not for everyone. Most people that are using this have very similar I/O from project to project. Because as you're going to see in the next half hour here or so, half hour plus, there's some setup time in the spreadsheet. There's some setup time at the drawing level. So if you do run or have similar I/O from project to project, it's definitely worth the time investment. If your projects are completely different from project to project, as far as the I/O is concerned, and I'm not just talking about the module that you're using. I'm talking about all the components that go to the individual inputs or outputs. If it's completely different for every single project, this might not be the tool for you. And you'll probably be able to decide that at the end of this webinar. So I'm going to start with the spreadsheet itself, because what happens is it takes information from a spreadsheet and applies it to a drawing. You are responsible for plugging in all of the information. And when I say information, I mean the I/O modules that you're going to be using, the addressing that you're going to fill in, the individual descriptions for the individual inputs and outputs, the components that are going to go to the input or output. So you are responsible for all of that information inside of the spreadsheet. The nice part is that out of the box, it comes with a couple sample ones. So at the very least, you're going to start with the correct format. You can make adjustments from there. So as an example, if I'm looking at this spreadsheet right now, column A, that represents the module that you're going to be using, the PLC module. That's the catalog number. The catalog number is tied to the symbol. You can use parametrically built PLC modules. You can use full unit modules. Software doesn't care. So as you're going to see, it uses a couple of these 1771 IADs, and then it has an output module down here. It's a little bit different. Another different one here. And you can mix and match, all day long. So you start with the PLC module itself. And then if you've ever inserted a PLC module inside the software, parametric wise, you can fill in a rack, you can fill in a slot, you can fill in a group. You're going to see those columns right up here. You're responsible for all the addressing for each module, as you can see. You have to fill that in the spreadsheet. This is just a generic terminal setup here. And then you're going to notice columns G through K. Those are the 5 lines of descriptions you can apply to any address. So when you normally insert a PLC module in the software, for each address, you have up to 5 lines of descriptions that you can fill in. Most people don't use 5 lines, but there are 5 available. And that's what G, H, I, J, and K are. So somebody's filling in each one of these descriptions for the individual address itself. We have a voltage attribute that you can fill in. And then you're going to notice, starting at column M as in Michael, going over to P as in Paul. It's got a border on the left and right side of each one of those. And you're going to see a pattern. The same thing holds true for Q through T, U through X, Y through AB, so on and so forth. These represent the individual components that is going to go to the individual input or output. You can have up to 9 components in series going to any input or output on your module. And as you can see here, this particular one is set up for, you have to plug in the tag, the description of the component if you have one, the name of the block itself, the name of the symbol itself. You have to know what the name of the symbol is that it's going to use. And then we have a location field as well. Now, when I get back into software, you're going to see how there are more fields available that you can add to the spreadsheet and then in turn map them to the utility when you run it. And I'll explain that in just a minute when I get into the software. Q through T, as you can see here. So basically on this first input, somebody's taking this to a terminal first. And as you're going to see in the drawing, it comes off the hot wire. So it's going to come off the hot wire, and in this case, it's going to go to a terminal. Then from the terminal, it's going to go to a push button. Here's what somebody's tagging it. You are responsible for the tags. Now the tags can be adjusted once the drawings are created through the update retag utility. So you have to put a tag in. You could leave it blank and then run updates later, but if it's a fixed tag, again, because if it's going to be similar IO from project to project, most of the time it's going to be the same. But I have seen people use this utility where they will put a tag in, but then once the drawing gets created, they'll update it to suit their standards or needs after the fact. So you put the tag of the component down, you put the description down. In the description, you know how there's 3 lines of descriptions you can use for any individual symbol when you place it down. What separates the descriptions is your pipe symbol on your keyboard. That's why it says cycle pipe start. When it actually creates the drawing, you're going to see that it's just going to be description line 1 is going to be cycle, description line 2 is going to be start. Once again, here's the name of the block. Here's the name of the AutoCAD Electrical symbol that I want to use. And then it has a location code. So it goes to terminal first, then it goes to a push button, then it goes to another terminal. And then as you're going to see, it's got some blank ones. It's got a couple of blank ones. And then finally it goes to one more terminal before it actually gets to your module. So in this case, somebody has 4 symbols in series that are going to go back to the individual address on the input module itself. And like I said, you could have up to 9. So I could keep going here if I had more symbols in series. So you are responsible in the spreadsheet for filling all of this information in, because it's going to take this information and apply it to the actual drawing. And this is just what the software needs to see. It's not going to physically draw any wires, let's say, from the spreadsheet. That's a portion of the setup inside of the utility as far as, okay, where's all this stuff going to land in my drawing? How do I know where the module is going to get placed down? Do I have 1 module? Do I have 2 modules? How does it know where to place the individual symbols in the drawing? Well, that's part of the utility inside the software. The spreadsheet is just about all the information that it needs to see, then it will apply all of this to the setup inside of the drawing. Whenever you see a blank row, that's where it's going to, and it's smart enough to know And because you're going to see this, I'm going to run a couple of different examples with a couple of different IO cards. It's smart enough to know if a module gets broken and stays on the same drawing, or if it'll put the next drawing or the next module in right next to it. And that's what's going to happen in this case. It's going to put 2 input modules down. And then it's smart enough to know when it sees another blank row to start a new drawing. And then it'll put the next 2 down in this case. So as you can see, initial setup time on your spreadsheet could take you a few hours. There's no doubt about it. And you have to have enough experience with AutoCAD Electrical to know the symbol naming conventions as well, because that's what that column is for. That's what this column is for. You're going to fill in the individual symbol names. So once you have your spreadsheet created, now it's time to take all that information that you already filled in the spreadsheet and actually apply it to a drawing or multiple drawings. You could create 2 drawings automatically at the same time. You could create 20. Whatever you have in a spreadsheet, that's what's going to get created. So now I got my spreadsheet all set. Now I want to apply it to create the drawings. So on my import export data tab inside of AutoCAD Electrical, I have the PLCIO utility right here. And I am defaulting to the folder that I'm using for this webinar. And as you can see, I have a couple of samples down here. I'm going to create more as well during the webinar. So I'm going to use this test PLC, this is the one that I just had open. And I'm going to pick open. And your first step is to go to the setup here. And I'm going to move this out to the right so I can explain what each category is in the setup. So when I go to the setup, the way that the actual utility draws wires is through the ladder command. If you have a little or a lot of AutoCAD Electrical experience, you probably know how to create or insert a ladder. We're doing that inside of the utility right here. And if I were to start in the top left corner, I'm just telling it this is the XY coordinate where I want the first ladder to land. Typical AutoCAD XY coordinate. Is it vertical? Is it horizontal? I'm going with vertical here. Reference numbers. Are you using reference numbers? Are you using the numbers with a ruling? Do you use an XY grid or a zone setup? So if you do use those formatting setups, you can apply this utility as well. And then the width right here is the distance between your 2 vertical wires, your hot, your neutral, your plus 24, your DC com, whatever. So that's the distance, just like a ladder. When you put a ladder down, what's the distance between my hot wire and my neutral wire? I have to fill that in. If I do have multiple ladders per drawing, because as you can see, this is set up right now for 2. What is the distance between your 2 ladders? What's the distance between this ladder and this ladder? This is the type of information that you're responsible for setting up. How many rungs do you want per ladder? If you've ever used the insert ladder command inside of AutoCAD Electrical, this is going to be real familiar to you. What's the rung spacing between the rungs? Do you want it to bump up by 1, or do you want the numbers to bump up by 2, meaning the reference numbers? You can also suppress rungs and erase unused ones. You have a signal arrow style. That's your, this particular style for the source and destination as an example. If you've ever inserted a source or destination, you've got an arrow to choose from. You've got an arrow that goes to a rectangle with a reference number inside of it. You've got the tilde sign. That's what these represent. This one's using the tilde symbol. Then in the top right corner, if you are using a parametric style PLC module, you have to pick the graphical style. Remember, when you insert a parametric PLC module, you have a few choices on the graphical style. If it's a full unit, you don't have to worry about it. Then it says input offset from neutral, and it's got 1 inch right there. What that means is the input module itself, which is right here, which is right here, what is the distance from the neutral wire to where you want the input module to go? That's what you dictate right here. If it's an output module, typically output modules get placed closer to your neutral, which would be in this area right here. You have to supply it that information. How much I/O per ladder are you going with? The I/O spacing is, 99.9% of the time. I don't know why it would ever be different, but that's going to be the same as your rung spacing. Scale, if you have a block that you scale for your I/O modules, you can plug the scale factor in there as well. Then it has inline devices. First input device from hot bus. What that means is, remember when I was looking at the spreadsheet, I'll recall it here. The first input device it went to was a terminal. The second one was a push button. Then it went to terminal again, so on and so forth. First input device from hot bus. This would be the first input device from the hot bus over here. So just like the spreadsheet in this drawing that I have open in this demo project, it's going to a terminal first. So what's the distance from the hot bus to your first input device? Doesn't matter what it is. Could be a terminal, could have been the push button like you see down here or over here. Doesn't matter. You have to supply it that distance. If it's an output, what's the output device distance from your neutral? And then you have spacing between multiple devices. That would be the distance, let's say, from this terminal to this push button. Then it goes to another terminal. What's the distance? Remember, you can have 9 in series. What's the distance in between each one? And a lot of this, as you're going to see shortly as well, when the first time you attempt it, it's trial and error. There's no doubt about it. First time I did this, my input module was outside the border. My symbols were so close together, I couldn't read the text out. So it's like, okay, you take a look at what you produced and then you make adjustments. And the nice part is, it's not like you have to, what did I change this distance from here to what there? You don't have to get your pen out, write it down. You can save all of the settings to a file. So the next time you go in, and I'll give you a demonstration of this in a few minutes, the next time you go in, you can just recall the previous dimensions you had, let's say, and then keep adjusting them from there. And this is the other part, we don't lie. This isn't going to happen in an hour, usually. It takes some trial and error. It's not as bad as the spreadsheet, let's say, time investment wise, but that first setup, might take you a little bit. And I've had some customers that do work with, they have multiple companies that they work with. They have multiple customers. They all might use similar I/O. They'll have a different setup for each customer. So they're still, they can still take full advantage of the utility, but they might have to change whatever that setup file is for each one. And then it has this spreadsheet table columns. This allows you to map your columns from the spreadsheet to the utility. And it's like, what the heck does that mean, right? Well, what that means is, take it as an example. Remember, when looking at the spreadsheet, column A is the catalog number. Notice module part number, number 1, which is column A. The address, 1, 2, 3, 4, 5, right? Here's the address that you fill in on the spreadsheet. That's why that is set up for number 5. Rack number, that's the second column over. Group number, that's the 4th column over. Slot is the 3rd column over. So you can map the columns to the proper number in order for them to show up in the order that you want. And then this is where I was talking about, you could also add columns to the spreadsheet and map them from here as well. So as an example on that one, I could have added a tag, a fixed tag. And what I would do in a spreadsheet, I'd probably, in this case, put the column, I'd make it, let's say, column G, or insert a new column here. And then maybe make that the tag itself. And then description 1 to everything would get bumped up by 1. So anything that you want to add to the spreadsheet, you want to keep that in mind when you actually map it to the utility. So again, as an example, we got descriptions 1, 2, 3, 4, 5 for each component, right? Those are actually in the spreadsheet, columns 7, 8, 9, 10, 11. And then we had that voltage one, column L there, which is number 12. If I pick more, and here's all the, basically up to 9 components in series. So column 13 in this case is the tag, 14 is description, block, location. But you could also add an installation column. You could add a manufacturer, you could add a catalog, you could add an assembly code for each of those individual components if you wanted to. Again, you're going to have to take a look at your spreadsheet, see where it falls in line, and just make sure you apply the proper number. And you're going to see how that is true for every single one. And it ends at 9, like I said. So this is how you actually map the columns from the spreadsheet to the utility. And obviously make adjustments if you want to. And then it has a drawing template. It's going to create a drawing for you. You're going to want to use one of your templates that you currently use to create a new drawing. Just make sure it's essentially a blank template with your title block. I have templates that I use a lot where the reference numbers are already there as soon as I create the drawing. I wouldn't use one of those because it does all that in the utility. So I'm not going to make any changes right now to that. And then we're almost done here. Now you have to start with your ladder reference number. What that first drawing, what's the ladder reference scheme going to be? I've got 9 drawings in this project. I'm going to make this 1000 for the start. When it goes from column to column in the same drawing, I just want it to use the next sequential. When it goes to the next drawing, I want to bump the number up by 100. So in the second drawing, it would be 1200, 1100, 1101, 1102, blah, 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 blah. And then it has things like module placement. Oh, I'm going to always start at the top of the ladder. You could make adjustments here. You could allow for predefined breaks, which we're doing. Typically, you're not going to use the active drawing to start this with. You want it to create a new drawing for you. That's some of the power behind the utility. So I'm going to browse out to the folder where I have this. And I'm going to call this PWG file name PLC-10. So I've got 9 drawings in there right now. It'll put the path in there for me. Typically, again, the reason why you're running the utility is you want it to create all the drawings for you at the same time. So I'm going to set it to free run. My sheet number is going to be 10. And I'm going to add them immediately to the existing project. And then as soon as I hit start here, you're going to see, and this is the power behind the software, it is impressive. There's no doubt about it. As you can see right in front of your eyes, it's going to create these drawings for you. So it's taking that information that was in the spreadsheet, it's applying all that information to a drawing via the setup, meaning where I went into utility, plugged in all my dimensions for the module placement, the ladder placement, the distance between, blah, 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 blah. And this is going to create 3 drawings for me. Now, if I go back to my project manager, you can see that it did indeed add these drawings. And I'm going to go back to the first one that it created. And if I take a look at the first few inputs here, I got a push button, cycle start is the tag. Remember, in the spreadsheet itself, there's the cycle start with the pipe sign. So if I were to edit this, just like any other component, description line 1, cycle, description line 2. And then we had stop, and then we had start. It's using a push button symbol. Location is field for each one. So let's say I go to the next project, right? Because my IO setup from project to project is very similar. So I go to the next project, copy the spreadsheet. There are changes to the IO. It's not an exact replica, but it's very similar. So now I'm going to go to the spreadsheet itself and make some changes to it. I'm going to, let's say, come over here. And for the second one down, I'm going to change the description to emergency. Remember pipe sign? Well, emergency stop. Instead of a normal push button, I need to replace it with a mushroom head push button. So in this case, the actual name of the symbol, all they have to do is add an M on the end for each one, because again, these are the AutoCAD symbol names. AutoCAD Electrical has a symbol naming convention. I'm going to follow it. And then I'm going to change the location from field to panel. So conceptually wise, I've only made a couple of little changes here, but think of it this way. You go from project to the next project. The IO is very similar. I'm going to go in and make some changes that I know that are going to affect the IO to the spreadsheet. Now I'm going to save this. And I'll call it test PLC _2 as an example. And I'll just close it down for now. So now, once again, hypothetically speaking, let's say I'm in a new project. I'm going to stay in this one just to save some time, but I go to the next project. And let's see, this is 10, 11, 12. Go to my PLCIO utility. I'm going to pick this spreadsheet this time. And I'm going to leave all the settings the same here. And I'll make this one 1300. Leave all this the same. And then I'll make first drawing here 13. And once again, I'll go free run, sheet number 13, and I'll start it again. So I copied the spreadsheet, made some changes, rerun it, and then my IO is done for that project. And you're going to see when it's done here, the changes that I did make. So now if I go back to my project manager and I go to this drawing this time, you're going to see now that we've got mushroom head push buttons for each one. We got emergency stop for this one. And the location code is set to panel instead of field. So that's the whole point of, okay, and who knows what you might be changing, right? We're just talking concept here. You saw me make some changes to a spreadsheet, save that spreadsheet, run it, and it's going to apply all that information. Well, you might swap out a whole card. You might swap out, the PLC module itself, which I'm going to show you right now. So who knows what you're going to be changing, but the whole point is copy the spreadsheet to your new project, make some changes to it, and you're done with your IO, period, of end of story. And speaking of, well, before I do that, two other things here. Notice in this particular example, the first component that comes off the hot runs right into, in this case, these push buttons, which is the second component. Also notice that when you have multiple ones in series, the distance in between, that's a little bit tight, as you can see. And this is what I was talking about, where you might have to make some adjustments to those distances. So if I go back to the IO utility, I'll use that same spreadsheet that I just used. This time I'm going to go to setup, and I'm going to change the first input device to 0.75. I'm going to spread out the distance in between to 1. And like I said, I can save these settings. Just saves it to a text file with this WDI extension. I'm going to show you an example of that in a minute. Whoop. Let me make sure that that took, which it did. So I'm going to rerun it again. And I'll use, let's say, 1600 this time for my lab references. And I'll go to here. So now you're going to see when I make some adjustments to some of those distances, it's going to look a lot cleaner. And that's what I talked about. It's trial and error. To nail it down exactly the way you want, you're going to have to run it a couple of times. And I would start small. Get your setup first, meaning start with, one drawing. One drawing with everything in it will get your setup in here as far as distances between components, the input module placement from the neutral, Start with one drawing. Start with a couple of modules. Get the setup from the utility done first, then just add to the spreadsheet all the information from there. So now if I go back to that first drawing again, now my first input device isn't running into my second one. I gave myself some more space with the distances in between. And those are the types of adjustments that you have to make. Now, I won't run it again right now, but as far as saving those settings is concerned, whoop, right now this is set to 1 and 0.75 over here on the inline devices. I'm going to browse to where I have a couple of these WDIs stored, and I'll go back to the original one. Original setup, if you will. Now if I go to setup, oh, I must have saved that as something else. Hold on a minute. And I do it the opposite. There it goes. I got the original and the other one messed up. So just trying to make the point, you make adjustments, save those. You'll get it nailed down to where you like it perfectly. And then you might have some different WDI files if you have different customer setups, let's say. Now, the last thing I'm going to show you is when you swap out a module. I'm sorry, when you use a different PLC module. So as an example, if I open up that original spreadsheet that I used, the first input module right here, 1771-IAD, okay? I created another one, and the only change I made is I've got a Siemens catalog number in here for the first module. Everything else I haven't touched. So let me go to a different project here because I've done a lot of damage. Not that I hurt it, to this one. Close these drawings down. And I'm just going to activate another project here. PLC_1. And it doesn't really matter which drawing I have open, since it is going to create new ones for me. So now I'm going to go to the PLCIO utility one more time. I'm going to grab the new spreadsheet that I'm going to use, again, with the only difference being the Siemens module versus the Allen Bradley one. And if I go to setup here, oh, let me do this. I'll go back to my WDI. I think it's this one I want. There we go. So from here, once again, I'll call this first ladder reference number 1000, bump it up by 100 between drawings. This time, I'm going to save it in the PLC1 project. Once again, just like I did before, first one. Sheet number 10. Free run. And here, add them to the active project. So all I've done in reality is change the first input module from an AB to a Siemens. In the spreadsheet is where I did that. And you're going to notice that the Siemens module that I chose is set up to break at a certain point. Utility doesn't care, because when you leave a blank row in the spreadsheet, that's where it goes on to insert the next module, whether it was in the same drawing or if it has to create a new one. Because in this particular example, you're going to see in a minute here how before it created 3 drawings. In this example, it's going to create 4 drawings, because if I go back to the original, or the first one, remember previously it used the Allen Bradley, which it didn't need to break the module, put it all in one. In this case, this Siemens one, you know, it's got quite a few commons. So it's pre-set up. If you were to use the insert parametric PLC module tool, you know, as soon as you insert it, it's going to automatically break it, because when you do create parametric ones, you can predefine breaks. And that's what this one did. So that's why, you know, now I'm looking at the Siemens module, and it does automatically break it. So if I hit my next project drawing, here's the second one that it created. Here's the third one that it created. And then finally, it created a 4th drawing, unlike the first time I ran it with the Allen Bradley, because on the Allen Bradley one, it didn't have to break any modules. And these are the types of things that you want to think about as far as which module you're using. You might have created your own, whether it's parametric or standalone full units. You know, you have to take that into consideration as far as how many drawings that it's going to create for you, because it does have that outcome. So the other thing I'd like to mention, I think I did in the beginning, on the individual components, the tag is predefined in the spreadsheet. One of the columns you have to fill in. Well, sometimes you might use this and then decide, well, you know, that's not really fixed to a particular drawing. So at this point, you could update all these tags. As an example, these drawings, if I look at the wire numbers, it's using the reference number. The drawing got created without using those reference numbers because they were fixed to the spreadsheet. If you do want to swap them back or have them, you know, have the tags be the same as the reference number, you just go one more step. Go to your update retag. Go to component retag, component cross-reference, because it'll probably affect those, and the wire number as well. So I could go through the whole project one time. Now it's all updated to the reference number. It's not fixed to whatever was in the spreadsheet. And that's just, you know, an example of how you could use this, you know, if your tags did change. So basically you want to use the same spreadsheet. You don't want to have to go in and change all those tags in the spreadsheet, because it would take you longer than the update retag command utility would do. If it is fixed, it's the same every single time because, you know, it is similar IO, you know, then you'll never have to touch those tags. All right. That is our spreadsheet to PLC IO utility.
Hey, Greg, we have a few questions for you.
Yep. Let me look right now.
All right.
I'll pull it out.
So the first question is from Ryan, and he wants to know the G3 from the spreadsheet is what exactly? The slot card per drawing?
G3. Well, let's take a look at the spreadsheet. G3 is your first description line of the component when it gets created. So if I go back, I'm sorry, not the component, the IO card. Take a look at the drawing. Then we go back to the first drawing that it creates. There's your bank number 1, fiber, waste removal blower, blah, blah, blah. There's your bank number 1, fiber, waste removal blower, so on and so forth.
Okay, Ryan's got another question. Is there a way to wire number, for instance, input 2/4 for this project, it has multiple devices on the same input in series. So in between those, we'd like to generally add a wire label that references the sheet line number until it gets to the last device, which would be the input number.
Well, first of all, let's see, the wire number. So you're using the address for the wire number like this is using?
Sorta. So if there's multiple devices on 108 or 1008,
Yep.
would it be possible to add wire labels that represent that 1008.
Well, here is, oh, whoa. I got you.
Yeah.
The way I would probably handle that, yeah, because it should have a wire number in here and here. The way I would probably handle that would be in my drawing property. Oh, good question. In your project properties, because this creates new drawings for you. Just like when you create it regularly, you create a new drawing and it asks you, do you want to apply the project default values? 99.9% of the time you say yes. So just make sure in your project properties that you have the search for PLC address turned on or the wire number format. Same might hold true for the component. Now, what you might have to do, because this came in wire number wise, like so, I'm using the address, but it didn't drop in any wire numbers in here or here. So what I would probably do is just go back to my automatic wire number command, project wide, and renumber it basically. So it's an extra step for sure, but it'll take you about 2 minutes.
All right, cool. Next is from Dave. Is it possible to define the wire layers using this utility, as well as having it automatically add the wire gauge label?
You can't add the wire gauge label, definitely not. And as far as the wire type that you're using, when you go to your create edit wire type, and you're still probably going to have to make some adjustments, because notice all of these are on the layer called wires. I would go, before I ran it, let's say, this is a terrible example, in this particular template that I chose, which is a terrible example, it only has one wire type called wires. You can choose a default wire type, which you'll have in your template that you're going to use to create the new drawing. So that'll give you, the proper size and color wire that you want, but you'll probably still, once again, have to make adjustments because it's going to be one default wire. So let's say you default to, 16 blue for everything. And then you're just going to have to go into your, neutral as an example, change convert wire type and give it a different one. So pick a default. It'll use that across the board. You'll probably still have to make adjustments from there. It cannot put leaders on there for you automatically, unfortunately.
Good thing to ask for. Okay, Nathan has a question. How do you connect two symbols that are the same device, such as an illuminated push button?
So, like, you mean if it took up two inputs?
I'm assuming.
Not quite sure. So here's an illuminated push button, if I understand this correctly. It's still only going to take up one output in this case, not input. Now, if you want two symbols that, are kind of in parallel, that would go from here down to here, two separate symbols. That again, two ways to think about it. If they're two separate symbols, then in the spreadsheet, you would list what those symbols are. Now, if they're if they're one symbol that you want to land basically on two rungs, the symbol will insert accordingly. So if you've got any symbol that would take up two rungs, then you would just put the symbol name in, for the one, and then the next one down, you would just skip it. So if it's two separate symbols, you treat them just like they are in the spreadsheet here. If it's one symbol that takes up two rungs, you know, then you would just plug in the one and it will, you know, drop it in just like you normally would drop in the symbol where it takes up two rungs.
Okay, Dave's got another question. If you leave the device tag column blank in the spreadsheet, will the tag automatically be created based on sheet number and wire number? I think you kind of...
If you leave it blank, kind of like I was talking about before with the wire numbers, you would want to go to the update retag and retag every component based off of your properties. It is an extra step. Yes, sir, it is. But when you run this utility, if you've ever run this utility, you know, it's extremely powerful and takes like 5 minutes, even on 20 drawings, let's say. So I would, you know, I would leave it blank in the beginning, just like this one right here, right? These are what I plugged in the spreadsheet. So that's what's going to show up. But my actual drawing properties and/or project properties are set up to read the family code and the sheet number. So even if you fill them in, whether you fill them in or leave them blank, if you want them to equal the reference number, you'd have to go back to the update retag for each one of those drawings.
All right, that makes sense. Now, back to Ryan's original question about the G3. He said it's actually located in the D1 cell. If you can go back to your spreadsheet.
The D1 is the group. Or I'm sorry, D1 is just the column header. Right? Here's D1, unless I'm missing something.
What does that stand for?
Well, when you create a module, you can include rack, slot, and group. Okay, it's just another attribute on the module itself. That's it. You could leave it blank. If you don't have a group, you know, normally when you fill in, if you normally put down, you know, a PLC module, this particular one is set up for a rack and slot. If I do have a group number as part of my whole PLC setup, then I would have included a group attribute on the module. If you don't have one, you don't have to fill it in.
Okay, now we have a question from Marcus, and I know the answer, but I'm going to let you do it. Does this tool only work with PLCIO and will not create power distribution drawings such as fuse block, VFD, motor circuits, etc.?
Yeah. Out of the box, you know, no. But I've seen people get creative with this. So I'm not going to give it a definite no, because, you know, like I saw someone create one time with it was a real goofy module. It was in the process industry, I believe. They didn't really use addresses, but basically they took the spreadsheet and really got thought out of the box, which you would have to do in order for it to create, like on distribution, right? You'd use a 3-phase ladder instead of a single-phase ladder. The PLC module itself, you could get away with maybe one circuit to represent a module. So you have to think out of the box. It wasn't built to do that. But I have some people get creative with it to have it create a drawing that isn't just a typical PLC module. So I'll say out of the box, it wasn't meant to do that, but I've seen some people get real creative, and it's just a matter, okay, it's not a PLC module, but this is the symbol that I want to use. So you put that in the spreadsheet. And then some of the secondary symbols that might be in series, you can add along to it. So that's the best. Out of the box, it wasn't meant to do that, but I have seen people get creative otherwise as well.
Yeah, I'm thinking one particular customer really took this to a completely different level. All right, so Robert's got a question. It's somewhat related. Can you use this programmer utility for instrumentation loop electrical terminations connected to the PLC?
Yeah, again, it's just, I mean, if you're showing something going to a PLC, you know, you can substitute any of those symbols that you want. So that would be a little bit easier than Marcus's previous question. And if you are starting with a PLC, just think of it as, okay, what symbols do I want to plug in here? Again, what both of these questions are about, and Julie and I have been asking this for a long time, you're looking for a true configurator. You want to start the spreadsheet and say, I got this, Bob, boom, boom, and have it create the drawing for you. It's hopefully we'll have one of those someday. It's not here yet, but once again, I've seen some people get creative to do that with this utility. That's the best I can say.
Yep. So Nathan had kind of a follow-up, and you and I both thought about this. If you've got like an illuminated push button, right? So the push button itself is the input, the light is an output. Can that be done?
If it's parent-child relationship, then sure. You put the parent that goes to the input, and then the child symbol that represents the output. You would just fill in the symbol in the spreadsheet in the devices that go back to the output, just like you would the input. You'd have to have two separate symbols. That's kind of like I was talking about before. We don't care what symbols you use or where you place them. So you would put the input portion, let's say that, anywhere that goes to the input, and then your child symbol, which is a separate symbol, you would show that, as a separate symbol going to the output where you want it to go.
That makes perfect sense. Okay, so I think you addressed this, but Michael has a question. Can you use custom IO module blocks as a template instead of the default? So, for example, we've dealt with some company standards that the box that they place a rectangle around the IO point text.
Yeah, there's nothing that's going to place a box around the text. If you're talking about like the location code box, where you can wrap it around multiple components, you would have to do that after it goes through the utility. It's not part of the utility. But you
right, but if a custom, if they create their own custom, their own PLCIO that has a box around that, would it still fill it in that location?
Well, if it's part of a symbol, of course. I mean,
yeah.
That's what I said before. You can use your own parametric PLC modules, which you would have added to the libraries from here. Now on the parametric, as you know, graphic-wise, this is all you get, right? You got a few different choices. So I'm guessing that you use full unit ones. So in the full unit card, whatever one you choose, you would, graphic, that's the difference between one of the differences between parametric and your own custom ones is, the full unit ones, graphic wise, you can make it look any way you want. It's part of the symbol, right? So make it graphic wise any way you want, and you can absolutely use full unit ones just like a parametric. You're not limited to either one. So whatever you have graphically that's part of the symbol, that's what's going to show up. If it's not part of the symbol, then you're going to have to draw it separately after the fact. So when I insert one of these modules, right, that's the graphics. That's what it looks like. If you had a dashed line around it, it's part of the block, it's going to come in with that dashed line around it. If it's separate, again, you're going to have to draw it separately after the drawings have been created.
Right, which goes to talk to what you talked about. You really need to sit, you're playing chess now, so you really got to, think ahead and what do you want to fill out. And as you said, start small, get that to work, and then, go crazy.
Yep.
Okay, Marcus has another question. In column F1, back to the spreadsheet, what does RTP reference? So F1. I didn't see
that. That is a group of terminals that it's placing down. Let's see, I think it's got a good explanation in the help menu. Oh, where are we here? Let's go to project. Help. Trying to see exactly. But it's basically, I know there's a separate area that calls this stuff out. It's essentially a group of terminals is what it is. That's what the column is set up for. So as an example, let's see, am I in the first drawing? The RTP. TB20, TB21, TB30. That's what is showing up there. I'm going to have to get back to you on that because I know it's set up for a group of terminals. I don't see them here right now. It's not, I mean, I wouldn't consider it a showstopper. If you don't use it, you don't use it, just like in any other spreadsheet, right? Or you could substitute to use it for something else. But what RTP word for word means, we're going to have to make a note and get back to you on that one.
I've got it. Must mean something to somebody. Okay, John is kind of following up back on that loop sheet. Can the utility be used to generate the actual loop drawings?
Like I said before, whatever is in the spreadsheet, that's what it's going to create. So you can substitute, the PLC module with another symbol. You can, if you have separate loop symbols, you would plug those into, the individual symbols that it can handle. The spreadsheet drives the data that's in the drawing. If you can make the data from the spreadsheet work in your drawing, then the answer is yes. Was it, again, meant to do that out of the box? It was made for PLC drawings, plain and simple. But, once again, I've seen some people use this for other types of drawings besides just PLC. So again, that's all I can tell you is that whatever data you have in the spreadsheet, it's going to apply it to the drawing.
So it's having both sides of that equation. Okay, this is a great question. Can you take an existing PLC drawing, export it to the spreadsheet so that you can use that spreadsheet going forward?
If you're talking about the, two spreadsheet utility, the answer is no, because when you run the two spreadsheet utility, it's taking existing data from existing drawings, and then you can make changes. And then you can bring that spreadsheet back in and the drawings will reflect those changes. But the format for the spreadsheet, when you use the export to, is completely different than the PLC format for the spreadsheet.
And that's not the first for that question.
Well, what I've always asked for is, and I think that, Derek's along the same lines here, is, you've got a project, and I totally agree with you. You did all the heavy lifting, right? You created the drawing, the IO modules, like you normally would. You want to be able to capture that data and then use it again. Unfortunately, you can't, because on the flip side too, I'd like to be able to capture all the settings, right? If I've got a drawing created that I did the normal way, I want to be able to capture the distance from my hop to my first symbol, so on and so forth. We can't do that either. It's like reverse engineering. I would definitely put that, if you ever visit any of the AutoCAD Electrical idea sites or any of the other sites, I would definitely make that a suggestion.
And just a note on that, folks, if you go to the AutoCAD Electrical forums, post those ideas, because Autodesk really listens and watches those forums much more than Greg and I kind of, yelling and screaming at them going, hey, we really want this. They will listen to you as customers. So it's just a good thing. If there's something that we can't help you with and we know, that's the way to go. All right, one more question from John. Do you know if Autodesk plans on an ISA loop sheet utility in the future? I'm going to answer that. I don't believe they have that plan. However, again, go on the forums and request things like that. And if you let us know that you requested it, we can do our best to follow up and say, hey, do you have these ideas?
Yep, absolutely.
And I'm sure Ashley can send out, when we export all these questions, we'll put answers in them so that everybody can get a document with them. Those are all I have.
All right. Well, thanks, everybody. Ashley, did you want to say anything else?
Yeah, I'll just remind everyone that there will be a short survey pop-up as we close down, and also a reminder that you will receive an email tomorrow which will contain a link for the recording so you can rewatch this at a future date. And that is all that we have. So thank you for the presentation, Greg. We thank everyone for attending today, and have a great day, everybody.
Thank you.